Hey guys, so we're starting a new area of study now, which is calculus. Now we're going to start with 9a, which is the derivative. The first couple of exercises in chapter 9, they're more so revision from last year. There's a little bit of new stuff, but it's mainly revision. So hopefully it's just exposure again, so we get a little bit more of an understanding. So in the area of study of calculus, it's pretty much all about gradient, but they'll use the words rate of change. So rate of change and gradient are the exact same thing. You probably used the word gradient more in the past, but it's important that we know that they just mean the same thing. Now there's a couple of different types in a way of gradient. There's an average rate of change and there's an instantaneous rate of change. Okay, so average rate of change, that's when you have 2 points and you're finding the rate of change of the line that connects them. So often you'll be given a function. So I'll just draw the graph of one here. And it might say that you want the average rate of change between 2 points. So this can be a point that you've been given, and this can be another point that you've been given. To find the average rate of change between those 2 points, we just need to find the gradient of that line. Okay, now we already know that to find the gradient of any line, we just need to use this formula. So you're going to be able to get your y2, y1, x2, x1 out of these 2 points there. Alright, so there's also instantaneous rate of change. Now, instantaneous rate of change means the gradient at one specific point. So this was over a bit of a span. This one's at one specific point. So I might use the same graph. But they might give you an x value and say that they want the gradient at that specific point. So they've given us this x value here, whatever it is. The instantaneous rate of change at any point is the gradient of the tangent line at any point. So if we want the gradient here, it's the same as the gradient of this tangent line. If we want the gradient here, it's the same as the gradient of that tangent line there. Same as any other point. So if we wanted it here, we might say the gradient at that specific point is the same as the gradient of that tangent line. Now we work out those gradients using the derivative, which we're going to go over pretty soon. Let's have a look at the first example here, and it is talking about average rate of change. So this is the rule that we've been given, and we need to find the average rate between these two x values. Now to do it, we need to find the y values that correspond as well. So that's where the rule is going to come in. So where x is -2, we need to use the rule to find out what the y value is, and same when x is 4, we need to use this to find out what the y value is. So when you do that, you're going to find that f of -2 is going to be 18. I'm just trying to save some time and space here. And f of 4, that's going to be 60. So that means when x is -2, y is 18. That's one of our points. And where x is 4, y is 60. That's our other point. So we need to find the gradient between these 2 points. Now remember, we're using this rule. Whoops, it's m equals. Alright, so once we substitute all those values in, we're going to be able to find the average rate of change between those 2 points. Here we go. So the average rate of change is 7 for that one. Now I've put this down here because you might see the word secant sometimes when we're talking about average rate of change, and it just means a line that's intersecting a curve twice. So if you look over here, we've got the blue is the curve, red is a secant line because it intersects it twice. Alright, so let's move down to the next one. Right, so we've been given this rule here, it's a parabola, and we want the average rate of change between the point where x is 2 and another point further along the line where x is 2 plus h. Okay, so they've introduced a plus h here. Now I just want to show you what this situation might look like. So the parabola that we're talking about is this one here. Now we want the average rate of change between where x is 2, so let's just worry about x is 2. So if x is 1 here, x is 2 is going to be something like that. Okay, so we want the average rate of change between this point and another point where x is 2 plus h. Okay, so 2 plus h must be an extra distance going over here. So we don't know how big h is. So it could be here, could be way over here, we're not sure. But I'm just going to choose a random point for now. So let's just say this bit here is 2 plus h. Okay, so that gives us that point there. Now, if that's 2 and that's 2 plus h, this distance between those 2 points, that must be h. Now, h could have been really small. It could have been just that bit there. H could have been really big, as I said before. We're not sure. I've just chosen this point. Okay, now, there's the picture of what's happening there. We need to actually find the coordinates of these 2 points, don't we? Okay, actually I might just finish it on this piece of paper and then I'll move it. Okay, so where x is 2, we need to find the y. So where x is 2, our y is going to be 1. So we got 2 and 1, so that point there is 2 and 1. And we need to find this point as well. So f of, remember the x value is 2 plus h. We need to work out what the y value that goes along with it is. So we're going to substitute our 2 plus h in. There we go. So we're going to have to make sure we can kind of expand this and then simplify. So there's going to be a fair few terms in here, but we're going to be able to put them back together. So we should end up getting, let's see, okay, so we've expanded and we've got that. Let's collect any like terms. Okay, done. So we've just worked out that where x is 2 plus h, y is h squared plus 2h plus 1. So this will work for however large or small that h is. So let me just show the point on our graph. Okay, there we go. And we wanted the average rate of change between those 2 points, didn't we? So we're going to go back to that gradient formula that we always use, because we have those 2 points. Okay, so we've got our y2, y2, y1, x2, x1. Okay, so let's simplify this again. Now, there's an h down the bottom. Both these terms up the top have h, so we can cancel that h out. There we go. So, that's our answer. That's our average rate of change. So, the average rate of change between this point and this point is h plus 2. So it's going to change depending on whatever value our h is. We don't know, but this is going to work for any value of h. Let's move on to the next bit. So as h approaches 0, find the gradient of the curve where x equals 2. So what that's saying is that if h is 0, well, what we were doing was finding this red line, finding the gradient of this red line. If h is 0, that means we're actually finding the gradient at that specific point, because we're finding the gradient between where x is 2 and where x is 2 if h is 0. So we're pretty much just finding the instantaneous rate of change there. Okay, so to do that, we just need to make h equals 0. So there's our rule. H plus 2. If h is 0, we can just substitute 0 in there, and we can see that the gradient at that point is 2. Now what we just did then is similar to first principles, because you might remember the h when you did it last year, but let's just go through it a little bit again. Let's pretend that you don't really know about it. So what we're going to do to start with is we're actually going to make the rule up ourselves. We're going to show how they got this rule. Alright, so if for any curve we want to find the gradient between any value for x and another value for x, show in general terms the coordinates of the 2 points along the curve. Now we need to be real general here, because we're not saying that x is specifically 1 or it's specifically 5 or whatever. X is just going to be x, because we can have any value. So one of our coordinates is going to be x, and we need to find out the y that goes along with that x. So to find out the y, we always do this, don't we? We just substitute that x value into the rule. So that's actually our first point. Now we want another point along the line. Now remember before we used 2 plus h as our another point along the line? We're not using 2 this time, because our first point was just x. So this time we're going to have x plus h. But we also need the y value that goes along with x plus h. So to do that, we'd substitute in x plus h. There we go. There's our first coordinate, and there's our second coordinate. Now b is asking us to find the average rate of change between these 2 points here. We know how to do that. We've already done it a couple of times. We're going to use that gradient formula. So here's my y2, y1, x2, x1. Let's put them into that formula and see what we get. Okay, so I've substituted it all in. Let's just simplify it here for a second. So you're going to see that x is going to disappear. There we go. So you see this here. If we wanted to find the instantaneous rate of change at a specific point, that would mean h is 0, isn't it? So that would be 0 and that would be 0. Now if you remember the formula for differentiation by first principles, it's this here. And this bit here is telling us that if we make h equals 0, that's going to give us our derivative. So remember this, this part here, this just means the gradient or the derivative. So what we've pretty much done is we've found the rule for differentiation by first principles. So this was average rate of change, wasn't it? Except if we make h 0, that means it's instantaneous rate of change. Okay, so that's where this rule has actually come from. Alright, so let's move on and have a go at actually differentiating by first principles. Now honestly, you're not often going to have to do this, and you'd only ever do it if it specifically asks you to differentiate by first principles, because as you guys learnt last year, there's a rule called the power rule, and we can differentiate super fast. So the power rule is actually in the next exercise, but you're probably going to remember it anyway. if we were going to find the derivative of that, the answer is going to be 12x plus 2. Now the reason I got that, or the way I got that, was you times the power by whatever the coefficient is, so that would become 12, and then the power goes down 1, so 12x, and then the x is just going to drop off here, as happens when x is just to the power of 1. So once we differentiate by first principles, this should be the answer that we get. Let's just see if we get that. Alright, I'm going to rewrite the formula down here. It's probably a good idea if you write it down a few times when you do the questions to make sure you remember it. You don't have to, but it's a good idea to remember these formulas. Okay, so this is the rule we're going to be using. Now, you can sort yourself out and put, you can show that f of x plus h is whatever and write that down here, but I'm just going to write it straight into the rule because I don't want to spend too long doing it. So, alright, now my f of x plus h. I already have f of x here. I don't want f of x though, I want f of x plus h. So wherever x is, I'm going to put in x plus h instead. There we go, I'll put in my f of x plus h, but now I need to take away my f of x. Now it's really important that you put your whole f of x in a set of brackets. I'm going to not do it right here and we can see what happens. Now we're supposed to take the whole function away. Without putting brackets, the negatives only applied to this first term, when it should have applied to that one and that one as well. So you need to make sure you put those brackets in, otherwise you're going to make a mistake. And down the bottom we just have h. Alright, so our next step here is just to expand everything out. You're going to end up having a lot of terms, you'll see. Okay. So if we do this, we're going to end up getting 6. Okay, so we expanded that top out. Now there's heaps of stuff there, isn't there? But what's going to happen is a lot of it's just going to cancel itself out, which I'll show you in this line. It's really important as well that you keep on writing your limit h approaches 0, because if you get down to the bottom and you've forgotten to do that, what often happens is someone will forget to substitute h is 0 in there, so you need to keep writing that down. It's a pretty common mistake. Alright, so let's see what we've got up here. Alright, now I'm going to start crossing things out because there is so much going on up here. Now, we've got a 6x squared. Are there any other x squareds? That should have been h. Alright, any other x squareds? So, x squared, another x squared here. So you've got 6x squared minus 6x squared, which is going to end up being 0, so we don't even need to write anything down for that one. Let's have a look at xh. So we've got 12xh there, can't see any other xh's, so we're going to have our 12xh down there. I'm going to get rid of it, so I know I've already done it. Now we've got h squareds. Are there any other h squareds here? No, so I'm going to keep that one here, cross it out, so I know I've used it. Alright, now 2x minus 2x, so they're going to cancel each other out. We've got a 2h, there's no other h's, plus 2h. Then we've got a plus 3 and a minus 3, so they'll cancel each other out as well. Alright, now we can see that there's an h in this term, an h in this term, an h in this term, and it's divided by h, so we're going to get rid of some of those h's. So it'll become 12x plus 6h plus 2. Now we can't really do anything else with this one, except we now need to make h equals 0. So if we make h equals 0, that's going to give us this, isn't it? So we're going to finish off with the derivative equals 12x plus 2. Now, was that the same as what we had at the start? Yeah, it was. Now, that took ages, didn't it? We did this in like 2 seconds. It took us a little bit to find this answer. So the only time you'd ever differentiate by first principles is if it specifically tells you to do that. Otherwise, you're wasting your time. We want to leave as much time as we can for other things. So, as I said, only ever differentiate by first principles if it specifically tells you to. Alright, so now for the exam questions. So this one here, we're asked for the average rate of change over this interval, so from where x is 1 to x is 5, and this is our rule. It's kind of hard to see that 3 there, so I've rewritten it. That is supposed to be cubed. Alright, so all we need to do here is just find out our coordinates when x is 1, our coordinate where x is 5, and then we'll be able to use our real basic gradient rule to work out what the average rate of change or gradient, because that means the same thing. Rate of change and gradient are the same. And then we're going to be able to work it out. So let's substitute 1 in, let's substitute 5 in, and find those 2 points. Okay, so we've got 3, so therefore one of our points is x is 1, y is 3, and we want the other one now. Okay, so 125 plus 10 is 135, and that's our other point, 5 and 135. Cool, now we can use our gradient formula. Which is that. Sorry about that. And substitute all our points in here. So here's our y2, y1, x2, x1. And 132 divided by 4 is 33. Yeah, 33. Okay, so we can see our answer is supposed to be 33. Let's look through our options, and 33 is E. There we go, so that one's finished. We move over to the next one. The question is pretty much exactly the same. They've just changed our rule here, and it's over a different interval. So we need to find the coordinate where x is 1, coordinate where x is 3, and then find the gradient between those 2 points, or gradient of the line that connects those 2 points. I'm not going to do it all here to make the video shorter because it's the exact same as before, but when you want to check your answer, it should be E.